Hello, everyone. Hello. Welcome to week number, oh my gosh, week number 3 of audio production training. I know we're here, you guys are not here with me. This is a recording, but I just want to let you guys know I miss you guys. I miss you guys so much. I miss seeing you guys in the chat. I miss Stevens already. I miss him already, telling me how the camera can be for him to see better. I miss the sister that says that the schedule is not right for her schedule. I'm starting trouble. I know that. So I miss you guys. Seeing you guys virtually. But hey, we're here. We're gonna get this training in. And last week we focused on mixing instruments and mixing vocals, balancing them out properly. We focus on how a vocalist can be mixed with a track if someone's singing to a track. So we had those. We spoke about those scenarios. We spoke about also. I believe we spoke about whoever starts off the service, starts the service, and what you would do in certain situations with the microphones. But today we're going to focus on what is on the channel strip of a digital mixer. So of course, later on in a few weeks we'll talk about analog mixers, but today we're going to focus on digital mixers. They are different in quite a few ways. All right, so let's start off with a word of prayer. Father, I ask that everyone that's listening understands, and their knowledge will be taken to another level. Please explain through me what needs to be explained. Say the way that each individual can understand what's being presented to them, and a change will happen. In Jesus' name I do pray, amen. Just to let you guys know, you can send me your questions in the Discord app, any questions that you have, and over the next few days I will answer them. All right, so let's start off with the first thing that's on a lot of channel strips, and that's phantom power, 48 volts. So what in the world is phantom power? All right, so I'm going to try to break it down as easy as possible. Phantom power is electric current, direct current, DC, that is sent to active circuitry. All right, so let's break it down a little bit more. Direct current, DC, we're talking about electricity here. Current that flows in one direction. All right, AC current is the wall outlets that you guys have. Everyone has in their homes, in churches, they have them, places of businesses. All right, DC current is normally the circuitry in like your laptop or something like, amps and stuff like that. I just be honest with you, I'm not an electrician. I am not an expert in electricity. So I am telling you what I'm learning, and it goes deeper and deeper. I know that. So for example, 48 volts being sent from an audio mixer to a to power a condenser microphone. We're about to learn about condenser microphones today. So there are microphones that need power sent to them for them to work. And on the mixer, you see a button that says 48 volts. And that button will allow the audio mixer to send power to this particular microphone for it to be able to work. It cannot work without that voltage or without some of them, they have a battery you could put inside of them. A lot of them are just through volts you send to them. And this is one of them, a condenser microphone. This is a condenser microphone. You've seen these before. These are called gooseneck microphones because they look like, they have a long neck. But these are the type of microphones. They're condenser microphones, all right? So there's a few different microphones out there. There's condenser microphones, there's dynamic microphones, excuse me. There's electrite microphones, but we're only going to focus on two today. We're going to focus on condenser microphones and dynamic microphones. So this is a dynamic microphone. Internally, it needs, because of how it's designed on the inside, it needs power to be able to, it needs voltage to be sent to it for it to be able to work, all right? And here's another example of a condenser microphone. Now, this particular microphone, you've seen this microphone used for choirs. So you have, let's say, a 30-voice choir, and there's, you have the tenor section that needs this mic. This mic is on a mic stand, and you have the soprano section. This microphone will be placed on a mic stand, and same thing with the alto section. All right, so these microphones require power as well. 48 volts is sent. You push the button down to send power through the XLR cable to be able to power these microphones so they can work. And you've also seen this microphone, maybe not this, literally this manufacturer, but you've seen the microphones that look like this in studios. So these microphones are great at picking up the details in someone's voice or instrument. So that's why people use them. And if you, let's say you see a microphone in your church or around your house, if you have microphones in your house that you're curious about, you want to see if it's a dynamic microphone or a condenser microphone, if it requires power, whatever the details, you can just look on, you could Google the manufacturer of that microphone and the model of that microphone. And if you Google it, you see a bunch of links like Sweetwater's link, Guitar Center, Sam Ash for a little bit, because Sam Ash is about to close down, actually. You'll find some microphones all over. The Google links will show you that particular microphone, excuse me, and even some others too, but that particular microphone. And once you click on one of those links, you can read up on that microphone. You could, for this microphone we just looked at, it's the, it requires 48 volts, phantom power. So you get information on what this microphone requires, what it needs, what it does, all on those websites that for the audio production companies that carry these microphones. They would have a description of as to what these microphones are capable of doing. You can even download the instruction manuals off of Google to understand more, to learn more about the microphones. It's a good way to know what you have, what you're working with. That's what I like to do. So where did the name Phantom Power come from? It's a weird name. So there are no additional wires to provide the phantom voltage. The same cable is used to carry the mic signal to the mixer and to carry the phantom voltage from the mixer to the microphone. One cable is used as a two-way street. Early condenser microphones, remember the microphone's a little, the big mic and then the small mic at the podium, condenser microphones. Condenser mic designs used additional wires, the early ones, used additional wires to deliver the operational power. Thus, the method to deliver Phantom voltage is unseen, i.e., you know, phantom method. Now, I got this information from Shure's website. They are a microphone manufacturer. They create other things as well. But I didn't want to take credit for this definition. I just, I kind of switched up certain things, but this, I got it from their website. And you can find this information online as well to help explain, to help answer questions that you may have when it comes to audio production. Now, this is your microphone from your church that's used for everyone on the pulpit. This is the Shure company I just spoke about, Shure. That's the name of the manufacturer. And then the model of that microphone is the PG58. All right, so you can Google that and you can learn about the microphone. It is a dynamic microphone. It does not require phantom power, 48 volts, to power it. This just requires batteries, either 9 volts batteries or AA batteries. And it's internally here is different. It's built differently. So that's level 2 this is level 1, by the way. Level 2 of training, which I'm working on for people that are interested, will break down inside of the microphones and the deeper knowledge of audio production, the deeper information, the next level, next layer of information. All right, so we also have DI boxes that require phantom power. So for example, you have an electric guitar. It needs phantom power for it to work. We have DI boxes that can give that as well. That can you have to send power to it to power the electric guitar. Some DI boxes actually have the 48 volts. You push the button and they'll send power to that instrument that requires it. Electric guitars, acoustic guitars, bass guitars, yeah. A lot out there. All right, so let's jump over to the next thing on the channel strip, and that's the mic gain. So this is on every channel strip on an audio mixer. And I'm gonna show you how to set the gain for a channel strip so you could get a good level of audio signal into each channel strip. I'm only gonna show you on one channel strip today. But this will allow you to be able to have enough volume for each of the channel strips. The more input gain you have, the more volume you have to work with, the more sound you get, basically. We're gonna go over that in a second. Just give me a moment here. I'm gonna get things situated for you to see. I'm actually going to use a handheld mic. This is a dynamic microphone. It is not a condenser microphone. It requires it's a wired microphone, so you could just plug this into this mic using an XLR cable. That's the 3-pin cables. I'll show you right now. XLR cables. I'm trying to, yeah, there we go. So these are called XLR cables. We could go over that another time, but plug right in. See the 3-pin there. You match it up, And when you know that is in, when you hear the click sound. There you go. All right. So I'm trying to untangle it here. All right. So let me show you something quickly. So this is the way I like to hold it close enough. You know, for black churches, they like to yell in the mic, right? So I like to hold it close up. This is when you first get a microphone and you want to set the gain. You want to set the adequate, you want to set, I'm going to show you, we're going to look at this over here to show you, so I can show you the gain structure, what knob to use and all that stuff. All right, so, but you would turn it, you keep turning the knob to be able to increase the amount of audio signal that you get into the channel. So this is my little mic that you see right here. This is a lapel mic coming through this channel. All right, and this is a certain knob basically called the gain, and you keep turning it, and you're able to increase the amount of audio signal that's coming into the channel. All right? So that's what we're going to do with this. It's a set and forget normally. Every once in a while, you have to raise up the gain because for certain different situations, for example, somebody's maybe very, very soft-spoken, but normally you set the gain and just leave it alone for a good amount of time. You won't need to touch it. I recommend that you don't touch it unless you know how to re-EQ speakers, because what can happen is that when you raise up the gain, you're basically opening, you're basically opening how much capturing, I'm trying to show you. Right. If the gain is low, I'm trying to show you on camera, you could get, the more you increase the gain, the more this microphone will pick up. This probably could work right here. So if you keep raising the gain, this microphone can pick up more. If you keep raising the gain, you can run into feedback, depending on how high you put the gain, all right? So we are going to set the gain. I'm actually, give me a second here. So I'm going to keep this mic right here the whole time, but I want to show you guys a different camera angle so we are on the same page, all right? Just give me a moment here, sorry. No editing allowed. Trust me, I was prepared. It's just once you hit action, that's when things want to fall apart. All right, so let me switch this. And all right, I believe you guys can see. So imagine the microphone is next to my mouth, like you just saw a few minutes ago. All right. Let me just get this. All right, there we go. So have the gain. Oh, let's go to the left. All right. So we have the gain, right? And we have the trim, all right? And look, 48 volts is right there, but we're not going to use 48 volts. We're not going to use 48 volts because this microphone does not require that. It's a corded microphone. That's dynamic. Dynamic microphones do not require that phantom power. All right, so let's get right to it. So give me a second here. Mic check, 1, 2, 1, 2. I'm gonna, all right. Let me mute my lapel mic. I'm muting this. Where is it? Right here. I'm muting this. All right, so just to let you know, sorry, I know I'm taking too long. If this right here, for those looking at the far away camera, this is the channel that we're gonna set the gain structure on, all right? I'm sorry, I'm trying to do this with one hand. Almost no hands, really. I just want you guys to get a good look. My fingers might be in the view a little bit, but we're gonna do this. Mic check, one, two, one, two, mic check, one, one, two, mic check. Mic check, one, two, mic check, one, two, one, two, one, two. Mic check, one, two, mic check, one, two, one, two. Mic check, one, two, mic check, one, two, one, two, mic check, one, two, mic check, one, two. All right, uh, so basically, I was trying to I was trying to make it easy for you to see close up. So let me give you an overview of what's going on here. So for digital mixes, we try to hit negative 18. All right, we try to hit negative 18. 1, 2, mic check. 1, 2. When we set in the gain structure, we want that to be a little consistent. If you're on an analog mixer, it's 0 dB unity, but this is a digital mixer, so it's negative 18 dB that you want the light to flash at. All right, mic check, 1, 2. That's when you're setting the gain structure. I'm not talking about whenever someone's just talking or singing, you want to consistently hit there. No, I'm not saying that. But when you're setting your gain structure at first, mic check, 1, 2. Negative 18 is just about hitting whenever I say mic check, 1, 2. So you're setting how much how much audio input you want to come into that channel. All right. And you would do that all across every channel, each and every channel, and you're basically creating a foundation of what you want when it comes to audio signal. So every channel will be just about equal to each other. All right. So let me give you an overview, a little explanation about my soundboard, the gain and trim. All right. So the gain for my soundboard, yeah, both the gain and the trim bring in adequate or whatever a certain level of audio signal that you want in that channel. But the gain larger increments. It skips numbers basically. You see those numbers there? 32.5 dB, yeah. So it skips numbers. The trim, it goes in smaller increments. So it's like it goes like, 0.1, 0.2, 0.3. When you turn the knob, it goes up. It goes up without skipping really that many numbers. So I use both of them. I use the gain and I use the trim. So I use the gain to kind of help me move faster. And then just if I need to just add a little bit, a few more decibel levels, go up a few more decibel levels, I I use the trims for smaller increments to get me to mic check 1 2 1 2 to just about -18. Mic check 1 2. All right. I mean, I would, depending on the environment. Let me give you an example. I'm about to switch the camera right now. Hold on for one moment. All right. So let me put this right here. Okay. So you guys can still hear me, right? Okay, good. So when it comes to this microphone, now this is the way I would set it for most black churches, to be honest with you. I say mic check 1 2, and I set the gain structure just the way you saw it. Now for corporate environments, it's different. I'm telling you, because corporate environments, uh, well, okay, not all corporate environments, but the one that I used to work at a couple years ago, some people would put the mics down here, and it's not the same people every day. We're talking about different people. We're talking about, because we're talking about companies that different companies every day that we work with, Fortune 500 companies. So you don't get the same person every day. You can't train them on the spot, because by the time they come in, it's time for them to do their meetings. So I saw a consistency in how they held the mics. They held the mics right about here, and you hear how the volume just dropped, right? Compared to it being up here. This is the proper way to hold a microphone. This is not proper. But hey, I couldn't retrain these people. So what I did is that I set the gain structure while saying mic check 1 2 from down here, since this is their normal way of holding the microphone. This is what fit that environment, the conference room. So since this is where everybody held the mic, this is where they're comfortable, I raised up the gain even more than what you saw me do over there, um, to get to -18 on that channel strip. So it depends on the environment. Sound engineers have to adapt to environments to do things that work best for that place that they're working in. Um, so yeah, so I had to put the microphone down here while I was setting the gain structure for that channel, and so there's enough headroom so we can hear them at where the microphone is down here. And I'm sure is probably kind of hard. It was kind of hard for you to hear me at that volume level down here. Yeah, because the gain is set for this type of talking. The structure, the foundation has been set for this mic talking. A person could get away with this, but down here, no, you would. From if you see someone in your church with the microphone down here, you can signal to them in the back, bring, give them a hand signal. That's it. And then they're like, oh, okay. And then they bring it up slowly but surely. And then you might see them drop it down a little bit more. You could give them the hand signal again and to bring it up. Or, get a little crazy with it. And they get it. They get it. Some people, you have to train them, but there's certain scenarios where uh, if everyone's holding the mic down here, you might have to, as a sound engineer, adapt to that and have your structure revolve around that. All right, hope you guys understand. I'm gonna switch back to my lapel mic. I don't really often like to hold the microphone. And you even might hear a volume difference between this mic and the lapel mic, because the lapel mic, I've done a lot of stuff to it, compression and I think I did some minor EQing. Yeah, I did some EQing. So I did some work to it to make it louder. Um, Zoom doesn't work well with my laptop, so um, there's a lot of settings, a lot of things, different things I had to do in the settings for this thing to work properly, for this lapel to work properly. All right, so hope you guys understand that. Please, if you don't, remember to ask me the questions in the Discord app, please. By the way, the lapel mic, since we're talking about microphones, the lapel mic, you know, is a long cable. I tuck it in my shirt, and on a different training that I'm creating, I'm showing people how to properly mic people with lapel mics. But the cable connects to the battery pack, and yeah, it takes double A batteries, and it has a clip right here, so you could clip it on to someone's belt. And this also works for the headset mic that you guys have for these pastors. You know, the ones that go right here. That's a good way to set it up. All right. So, well, we actually have, I would save the gate. I have this thing called a gate that I'm supposed to teach next. But I think that, you know what, I have about 10 minutes. Let me see if I can run through that. And let me remove this so you can see me again. All right, so let's go to the gate. Now, I probably might need to continue this for next time, but let's briefly go over it. So we have the gate. It is, probably you guys are wondering, what is a gate? But it's a tool that you can use on a digital mixer. And if you were to use it on an analog mixer, or if you wanted to use it on an analog mixer, you would have to get an actual physical unit that has a gate on it, and it would you would have to plug it in using cables to the analog mixer. But like I said, that's a different thing that I would teach you guys. All right, but yeah, so let's get to it. So the gate is also called a noise gate. A noise gate, or simply gate, is an electronic device or software that is used to control the volume of an audio signal. All right, so you can use, I'll explain it later. Comparable to a compressor, which attenuates signals above a threshold, such as loud attacks from the start of musical notes, noise gates attenuate signals that register below the threshold. So basically, it lowers the volume of that signal on that particular channel. Almost like mutes it, depending on how you set the gate. So how to use the gate? Let's go over this actually. I have only 6 minutes and change left. All right, so I'm not even gonna show you any examples today. Next time I'll show you an example. So basic controls on the gate. threshold, ratio, attack, release. Threshold, the threshold of a gate, of a noise gate, decides how loud the audio signal needs to be for the gate to turn on. Once the audio signal reaches the same volume as the threshold, you'll be able to hear it. These are one of the tools in the gate. Ratio is another one. Gate's ratio value determines how heavily your audio signal will be attenuated when it breaches the gate's threshold level. For example, the ratio is set to 4:1. Well, of course, there's math to a lot of these things. When you turn the knob, you see the different numbers. So one of the settings, 4:1, will allow for more signal to be heard, which is good sometimes depending on what you're dealing with. Now, it'd be more signal to be heard than 100:1. 100:1 is pure silence. So we'll play around with that next time, actually. Attack, how fast the gate will open for the audio signal to pass through. Note, a fast attack setting is good for transient instruments like the drums. The release sets how fast or slow the gate will take to close. Note, the release should be set so that the natural decay of the instrument or vocalist is heard. If the release is set too early, you will hear the instrument or vocalist sounding choppy, like you cut in and out. Sometimes, yeah, just like that, almost like somebody stuttering. It sounds like when it's not set properly. But I only have. I don't have enough time today. I only have really 4 minutes left. I don't even want to just move so quickly on this. This requires you to have some time to see and hear what a gate does. Most likely, it's easier to show you on the kick drum for you to hear it at work. So I saved that for next time. But I'm glad that you guys watched this video, you watched until the end. Almost 40 minutes. So next time we'll go over actually how the gate works. I'll show you on camera and we'll go through it together. You'll hear certain things, you'll see certain things. You'll be able to ask questions live. That's what I like to do. I love live presentations, so you can have the platform, the space, the floor, I should say, to ask the questions in real time. All right, so next time we'll go over that. And I believe that this Saturday, what is it? The 20th? Let me see if I have my dates correct. Well, the 20th. Well, that shows how tired I am. The 18th, this Saturday, 18th, maybe Saturday night, that we should do the next class. Of course, we'll discuss that in Discord. Thank you so much for joining today. Hope you learned a lot. And if you need to replay this, replay it and study it, because what you put in is what you get out of this. All right, take care now, guys. All right.